Hello students, welcome back to the classroom point. In our today's class, we shall discuss a different category of the methods in which concentration can be calculated. Here, we have already seen that how to calculate the concentrations in the molarity, molality, normality, mole fraction in our previous classes. So in today's class, we shall see how to calculate the concentrations when percentage in terms of the percentages. So there are some categories in that. Let's begin the class now. So here calculation of concentrations in terms of percentage. So here we have to calculate how much amount of the solute is present in the given mass or volume of the solution, that too in terms of the percentage. So here then that first one is mass percent. It is also known as percentage by mass. So it is always shown like that, W by W percent. You have to remember one thing, that the numerator value always represents about the solute, and the denominator value always represent about the solution. That means here both solute and solution are given in terms of the masses only. Hence it is called as the mass percentage. Now let us see the definition here. The mass of solute in grams present in 100 grams of solution is called mass percent. Why we have taken 100 grams means here percentage is always for the 100 only. That's why we have taken the 100 grams of the solution. So every time we have to calculate only for the 100. In terms of the mass means 100 grams. In terms of the volume means it is 100 ml. Now let us see the definition here. W by W percent, that is what mass percent equals to. So let us transform this definition into the formula. Mass of solute in grams divided by mass of solution. This mass of solution also to be taken in the grams, because both must be in the same units, into 100. What about if mass of the solution is not given but mass of the solvent is given? So we know that mass of solution is equals to mass of solute plus mass of solvent. So this is always 100% is true. Whenever you take the mass of the solute and the solvent in terms of the masses, when you add them, obviously you will get the mass of the solution. And here one more thing here is, see, both terms are in the grams, mass of the solute and mass of the solution. So grams cancel out the units. That's why mass percent don't have any units. And one more thing here is, since mass terms are involved, mass is independent of the temperature. So even temperature changes, mass do not change. Hence mass percentage also do not change with the change of temperature. So here we can write down that mass percent has no units and is independent of temperature. Let us take some examples how to identify the given concept in terms of the mass percentage. So example is, imagine 0.46 W by W percent of NaOH solution means that so this value always stands for the solute, that too in terms of the mass. So this value always refers this first term. Second term is always about the 100 grams. That's why here we can write down that NaOH in grams present how much? 0.46. So that means that 0.46 grams of NaOH is present in 100 grams of solution. So let us solve some simple question. Find the mass percent of a solution obtained by mixing 2 grams of A in 8 grams of B. So here lesser quantity substance is always called as the solute. That's why mass of solute here, mass of solute, that solute is A, its mass is equals to 2 grams. Larger quantity substance is always called as the solvent. So here mass of solvent B is equals to 8 grams. But according to the definition, mass of the solution we have to take it. So that's why for mass of the solution equals to mass of the solute plus mass of the solvent. So that's why here mass of solution is equals to mass of solute 2 grams plus mass of solvent 8 grams. That value is equals to 10 grams. Now let's calculate mass percent. That is W by W percent equals to mass of the solute 2 divided by mass of the solution 10. That value equals to 0.2%. Is the weight by weight percentage of the solution. Now let us see another concentration term which can be represented in terms of the percentage. So the second one is volume percent. It is represented by V by V percent. Here also same thing. The numerator tells about the solute, denominator tells about the solution. So here volume by volume means both are liquid. So this volume percent is applicable to the solutions which are obtained by mixing 2 liquids. So solute and solvent must be in the liquid state. So final solution you are obtaining is also in the liquid state. So let us see here. It is the volume of solute in milliliters dissolved in 100 ml of solution. So let us transform this definition into the formula. Volume by volume percent is equals to volume of solute, that in ml, divided by volume of solution in ml into 100. Then here we have seen that mass of solution is equals to mass of solute plus mass of the solvent. Can we get the same thing in terms of the volume percentage? Sometimes we may get, sometimes we may not get. Let us see in which cases we will get, in which case we cannot get. See, volume of solution is equals to volume of solute plus volume of solvent. This is applicable for ideal solutions. So in terms of the ideal solutions, by mixing of the volume, change of volume is equals to 0. There shall be no change in volume. That means if you take the 100 ml of the solute and add it with the 500 ml of the solvent, you will get the 600 ml of the solution. That is only for the ideal solutions. Then what about the non-ideal solutions? So volume of solution is not equals to volume of solute plus volume of solvent for non-ideal solutions. So in terms of the non-ideal solutions, delta V value not equals to 0. That means by adding the solute and the solvent in terms of the non-ideal solutions, the total volume may increase or may decrease. That's why only in terms of the non-ideal solutions, you cannot add up the solute and the solvent volume. But in terms of the ideal solutions, we can add up the volume of the solute and the volume of the solution. So here also, see ml are involved, means both are in the same units, so that units get cancelled. So volume percent also do not have any units, but it depends on the temperature. So some question may arise. By raising the temperature, since both volumes increases, then how it affects the volume percentage? So the increase in the volume may differ from the solute to the solution. Solution volume, because solution is having the another chemical component, that is solvent. Both may not expand to the same extent. That is the reason why volume percentage depends on the temperature but has no units. So we can write down here that volume percent do not have any units and depends on temperature. Let us take an example here. For example, 0.49%, that means volume by volume percent of ethyl alcohol C2H5OH solution means that its meaning is so this value always, as I said earlier, always refers the volume of the solute. Second value is about the volume of the solution. So it means that 0.49 ml of ethyl alcohol is present in 100 ml of solution. So like this, we can understand the volume percent. Now let us see another percentage calculations. Now third one is mass by volume percent. So this means W starting term is mass, so that W, second term is volume, so that we take the volume percent. So it says that it is the mass of solute in grams present in 100 ml of solution. So that first term is mass. So that solute mass, solute value we have taken in the grams. Second term is about the volume, that is about the solution. So that here we have taken the 100 ml of the solution. So here we can write down that mass by volume percent is equals to mass of solute in grams divided by volume of solution in ml into 100. See here it is grams per ml. So it has the units. There is no cancellation. At the same time here volume is involved. So when temperature rises, volume of the solution also increases. When volume of solution increases, its percentage value means mass by volume percentage value decreases because they are inversely related to each other. So here we can write down that it depends on temperature and decreases by rising the temperature. What about the units? Units are grams per ml. What happens if sometimes volume of the solution is not given but other terms are given? We know that density of the solution is equals to mass of solution divided by volume of solution. So volume of solution, if you bring this side, so volume of solution is equals to mass of solution divided by density of solution. So this volume of solution we can substitute here. So here we get the W by volume percent is equals to mass of solute in grams divided by, instead of volume of solution we can take the mass of the solution that too in grams into, so this denominator density value goes there, so the density of solution into 100. And we also know that in the previous previous session we discussed that mass of solute by mass of the solution into 100 is called the mass percentage. So this value, this entire term we can replace by the mass percentage so that we can get the mass by volume percent is equals to mass percent into density of the solution. So by using this relation and knowing the density of the solution, we can interconvert the mass by volume percentage and mass percentage. Now, let us see how to understand the mass by volume percentage questions 10 and its terminology. Imagine 49 or else 4.9 W by V percent of H2SO4 solution means that 4.9 grams of H2SO4 is present in 100 ml of solution. So starting term is about the solute in terms of the mass and second term is about the solution in terms of the volume. Now let us see the another term, that is parts per million. It is known as ppm. So what is the meaning of the parts per million? Usually this parts per million is used for the measuring the concentration of the solute for the pollutants, because usually pollutants are present in the very less quantity in the nature, so their concentration cannot be measured by using only 100 ml of the solutions or 100 grams of the solution, because very less quantity is present in the large quantity of the solvent or solution. So that is the reason why here we will take the 1 million parts, means 10 power 6, 10 lakhs is called as the 1 million. So if you take the liquid, that means the volume of the solute in ml present in the 1 million ml of the solution, that is called the parts per million. In terms of the mass also we can take it. Now let us see the definition. It is the number of parts of solute present in 10 power 6 parts, that means 1 million parts of solution. The thing here is, this number of parts you can take either in terms of the mass percentage, or you can take the volume percentage, or you can take the mass by volume percentage. See, let us see how to use this one. So ppm is equals to number of parts of solute, I am taking in grams, divided by, and here mass, here we have taken the solute in grams, so I am taking the mass of the solution. So number of parts of solution in grams into 10 power 6. So this 10 power 6 we can write down as a 10 power 2 into 10 power 4. So ppm is equals to, now see, mass of solute in grams divided by mass of solution grams into 10 power 2, that means mass percentage. So here we can write down that mass percent into 10 power 4. We can convert the ppm into mass percentage and mass percentage into the ppm also. Now what about if I don't take like this, but I have taken the volume by volume percentage? Then also similar concept, ppm is equals to volume percentage into 10 power 4. Then what about if I take solute in the grams and the solution in the milliliters? Then here also you take the solute in the grams, solution in the milliliters. Then ppm can be written as mass by volume percentage into 10 power 4. So this number of parts never says about only the mass, it also says about the how many parts. So that part meaning is, you can take the parts in terms of the grams, in terms of the volume, or both in grams to the volume also. Let us see one simple definition how to understand the ppm question or terminology. 15 ppm of CHCl3 in seawater means that 15 grams, I am taking in terms of the grams now, 15 grams of CHCl3 chloroform is present in 10 power 6 grams, means that means 1 million grams, 10 power 6 grams of the solution. Solution means here it is nothing but seawater. So that in this case solution is equals to solvent. Why? Because solute quantity is almost negligible. So that's why we can take the mass of the solution is equals to mass of the solvent for only ppm calculations. And as I said, ppm is used only for the means measuring the concentration of the pollutants. So this is today's class. I hope you understand. If you have any doubts, please do send your doubts to the classroom.point@gmail.com, and do not forget to subscribe the channel. Thank you.